In this video, we're going to talk about object-oriented programming in Scala. Scala is mainly known as a functional language, but it also has some rich object-oriented programming constructs, and you can use it perfectly fine as an object-oriented language. Let's start off with a very simple example. We're going to use the class keyword to define a user class. The user class is going to be instantiated with a string. And it's simply going to assign a value, name, equal to that string. On line 5 here, we're going to assign a variable u equal to an instance of the user class. So the new keyword is used to instantiate classes. And in this case, we're instantiating the class with the keyword, with the string Frank. I'm going to paste this code in the console so we can play around with it a little bit. Alright, let's copy this. I'm just going to paste this into the Scala console. Alright, so now we can see we have u that's returning an instance of the user class. If we do u.name, it will return Frank. Okay, that was a very gentle introduction. Let's move on to an example that's a little bit more complicated. So let's take a look at an example with a method. So in this example, we have a cat class. The cat class is instantiated with a string. The cat class has a greet method, which returns a string, and that string uses string interpolation to return my name is, and whatever the value of the name variable is. On line 7, we're assigning the variable myCat equal to an instance of the cat class, and that the name of this instance is going to be Garfield. On line 9 through 11, we're going to call the greet method of the cat class. So let's run this code, and it should return my name is Garfield. It takes a little while to run. There we go. My name is Garfield is printed. If we change this to be Darla, this will print my name is Darla. So this is an example of a method in Scala's object-oriented programming. This is the greet method. Alright, move on to the next example. In this example, we're kind of mixing up Scala data structures. So we're creating a singer class. The singer class is instantiated with a string. On lines 3 and 4, we're creating two instances of the singer class. One is instantiated with Miley, the other is instantiated with Bradley. On line 6, we're using a Scala list to create a collection of singers. And then on lines 9 through 11, we're using the map method, which is passed an anonymous function that will be covered in later lectures. And it's basically generating a new list, which is just the names of the two singer instances. In this case, we're just going to create a new list. The first element's going to be Miley, the string Miley, and the second element's going to be the string Bradley. Let's run this code and we'll see how it works. So we do Scala 03. Alright, so we can see that that worked as expected. It's creating a list of the strings Miley and Bradley. So this example is mainly just to demonstrate how the different Scala data structures can be mixed and matched. Let's look at the next example. And this is updating a variable in a class, or more specifically, an instance of a class. On line 1, we are defining the mango class, and it's going to be instances of this class are instantiated with a string. On line 3, we create a value. It's called myMango, and we are making an instance of the mango class, and it's initially going to be set to ripe. So when we call mango.status the first time, it's going to return the string right. And then on line 6, we are updating the status to be the string rotten. When we call mango.status the second time, it's going to return rotten. It'll be easiest to demonstrate this code in the console. So let's actually cat this out and copy it over to the console. Alright, so now we have an instance of myMango. We can see it returns an instance right here. So if we do myMango dot status, it will return right. If we change that to happy mango, and then we do myMango.status, it's going to return happy. The reason we're able to update this variable is because we defined it using the var keyword. If we had defined this using the val keyword, this would error out. Alright, now we're ready to move on to the next example. So I think we're on 05. So in this example, we are creating a kitchen class. The kitchen class is instantiated with 2 arguments. The first argument is the color. The second argument is the floor type. And the kitchen class has one method, which is called describe. And describe returns a string, which is the kitchen has floor type floors. So what we can see with floor type is it has a default argument. So what this means is that if floor type is not set, then it's going to revert to the default value. If floor type is set, then it will use whatever it's set to be. All right, kind of said that awkwardly. So in this case, we are omitting the value for floor type, so it's going to use the default value. Let's take a look at this in action. So we can see that this returns the kitchen has tile floors. The reason it's returning tile floors is because it's falling back on that default value because we never set it. So if we change this up and let's do wood, and now we're actually overriding that default value. We're setting it so it's not going to fall back on the default value. So we can see when this is run, it's going to say the kitchen has wood floors. So default values make it so that you don't need to supply all the arguments, and that there's some smart defaults to fall back on. All right, let's move on to the next example. 6. All right, so now that we've covered the basics of classes, we can move on to some inheritance. So on line 1, we're defining a class A, and it has a single method called hi, which returns hello from A. On line 4, we are defining a class B, which extends from A, which means that it's inheriting from A. On line 6, we are creating an instance of the B class using the new keyword. So since B inherits from A, that means it has access to all the methods defined in A. So when we call binstance.hi, it's going to return hello from A because B has access to this method that's defined in A. Let's take a look at that. So we can see that that works. Hello from A is returned. It's because B is inheriting from A, and therefore it has access to all the methods that are defined in A. All right, I think we have one more example before we're done. Let's just check there. Yep, just one more example. This is an example of using super and override. So here we have a class called tree. Tree is defining an about method, which returns the string, I am made of wood. On line 5, we're defining a second class called pine, which is inheriting from tree. And we're also defining an about method in the pine class. Since the pine method about is going to return something different, we need to use this override keyword. In this case, we want to use the value that's in the superclass, in the parent class, which is super.about. So super.about in this case returns I am made of wood, and then we're going to concatenate that with and sticky. So in this case, when we instantiate the tree class and call the about method, it's going to return what's in the parent class, which is I am made of wood, and then concatenate it with the string and sticky. So here we set the variable apine equal to an instance of the pine class, and we are printing apine.about. So we can see that that will return I am made of wood and sticky. Alright, so we covered a lot in this lecture. I recommend you do the quiz that's linked in the description to practice what we just covered, and I hope you enjoy object-oriented programming in Scala.